So that should be fine, right?
Mm-hmm.
Okay. So the maximum, question C is the maximum acceleration. It should be A omega square. So A omega square should be 0.1 times 3.65 square. You got 1.33 meter per second square. Okay. And then the next one is, and where does this maximum acceleration occur?
When the
At maximum displacement,
yeah.
right? The force from the spring is very high, or this side.
Right.
Determine the total energy of the oscillation system. From here, we already determined that's the total energy, right? With maximum displacement, it's all in the potential energy. At equilibrium position, it's all in the kinetic energy. So you can calculate either of these, and you can get 0.1. So that's D. So the last question is express the displacement as a function of time. So we know the basic function is A sine omega t, and here A is 0.1, right? 0.1 meter. Sine omega is, from the calculation we got 3.65 t. And the other thing is we need to know when t is equal to 0, x is 0.1. So when t is 0, here should be 1. So we just need to change sine to cosine. So actually here is 0.1 cosine. Okay, that's the equation. And the next question is a pendulum. Has a period of 2 seconds on Earth. For this kind of question, it's the same as spring. So all the t should be 2 pi times square root L over G. That's the equation. Just need to calculate. Because t is 2 seconds, 2 over 2 pi is equal to this, right? Just move this 2 pi to this side, cancel 2. So L over G, take square, both sides, pi square. So we want to know the longs. Will be G over pi square. And if you plug in the number, G is 9.8, pi is 3.14. So it's close to 1. Because here's 9.8, 3.14 square. It's close to 1. So this question is A. The next one is quite similar to this one. It's also a simple pendulum consisting of 20-gram mass and the initial angular displacement 8 degrees. And then you release, it starts to oscillate with a period of 3 seconds. Okay. And then with the same way, you can calculate L. And that is 9/4 pi squared times G. If you calculate, it's 2.236 meter. Okay. That's the length. And then the period. We know the period is 2 pi square root L over G, right? 2 pi, that's constant. Pi is 3.14. Nothing can do with those numbers. So the only thing it depends on is the length and the gravity, right? If you use the same system you put on the moon, it will be different from here on the Earth. So the following 4 questions are similar questions. Does the period of the pendulum depend on the initial angular displacement? No, because no matter if it's 8 or 10 degrees, the period will be the same. And C depends on the mass of the mass? No, because we don't even need to use amp here. And then D is depend on the length? Yes, because the length is here. And E depend on the acceleration due to gravity? Yes, because this G here, okay? So that's conceptual questions. Okay. We're done with this one. And then,
No, yeah.
huh? More?
Yes. You missed it. Don't tell me you missed those.
I didn't see those.
Okay, don't worry about it. Let's move on.
No, I can do those. Those are.
No, because you're gonna waste time. Do the ones you already wrote down. Go from here.
I did those. Those are same as these ones, no?
Yeah, but they're different questions.
It's the same question.
They're the same.
Exactly the same. This one is similar to me.
Do you
They're
think you can
exactly
answer
the
them?
same. Huh?
They're the same?
They're the same question.
Okay, we go. Answer them.
Okay, so the first question is a plastic block of dimension block, okay, 2 by 3 by 4 centimeter, has a mass 30 grams. What is its density? The density would be the mass over the volume, right? That would be the density. The mass is 30 grams, the volume 3 times 2 times 4, 24 cubic centimeter, right? And then if you calculate, you got 1.25 grams per centimeter cubic centimeter. So that's the first question. The second question is a brake, same as this one, weight 50 Newton. Weight 50 Newton. And the measure will be 30 centimeter times 10 centimeter times 4 centimeter. So we can write as 0.3 times 0.1 times 0.04 meter. Okay? So you have a brake like this.